Welcome to Earth Science, everybody. Your job is going to be to calculate a rate of change for each of the sections of the lab, which would mean, like, with the sand and the water, that's 4, because we're going to have the sand as it heated up, the sand as it cooled down, the water as it heated up, the water as it cooled down. What maybe should have had on your graph, once you graph, or in your head, we started at a temperature, right? This is a very loose graph. Don't worry if it's not exact. And your sand heated up and it got to a peak. That took 15 minutes. And then it cooled down back to probably somewhere near where it started. Maybe so, maybe not. Maybe this will all look a little different, but it'll be roughly like that. You had water that probably started somewhere around the same and heated up by not by as much and came down, didn't cool down as much. That'd be like really ideal looking data. Now, there are experiments, everybody's doing different things. Maybe some things went slightly wrong, but we can still work with this. What we're going to do for a rate of change is basically a speed. It's also kind of like doing a slope. So if you remember gradients, it's kind of the same thing. So what you're going to do for each of these, again, each of the 3 sections of the lab will have 4 of these problems that I would like you to figure out. What you're going to do for each of them is a rate of change problem. Now, if we pop over to the reference tables, good old New York State reference tables, here it is right here. Rate of change is change in value divided by time. And again, it's a lot like gradients if you consider this as a slope, because it's the slope of the line of this graph. If that's complicated, don't panic about it. We can still do a rate of change, and you're very used to calculating rate of change because miles per hour is a rate of change. Speed is a rate of change. What does your value change divided by how much does your time change? If you drove 120 miles and it took you 2 hours, what's your rate of change? It's 120 divided by 2. It's 60 miles per hour. We're doing that. We're doing a rate. We're doing a speed at which the temperature changed. All right. So here's how you're going to do it. And your job is to go into your data and do this. Don't write down my numbers. You can do this kind of like you did with the your own lab data. You can do it in your marble notebook if that's what you did. You can just do it anywhere that you're going to hold on to it until it's time to put together this whole report. How much did the temperature go up? So let's say we're doing the water. The sand. We'll do what the blue line would have been. I'm just making these numbers up. Please don't write these down. Let's say that it started at 30 degrees C and it went up to 50 degrees C. So a rate of change would be how much did it change and how long did that take? If you remember, we did these labs like in 2 sections. We heated up for 15 minutes and cooled off for 15 minutes. So if we went from 30 to 50 over the course of 15 minutes, that's really all this problem is. We'll say it went up or down, doesn't really matter, by 20 degrees C, and that took 15 minutes. There's your problem. That's it. Grab a calculator. 20 divided by 15 is 1.33333. We'll call it 1.3 equals 1.3. And then your label is sitting right here, degrees C per minute. When we do our official report on this, this is how you get your points. I want to see the setup. How many degrees was it? Divided by how much time was it? They'll all be 15 minutes. That'll be easy. Equals what the speed was, the speed that temperature changed. And that'll be great. Okay. Now, if it goes down, we don't have to do negatives. It's only a change in value. Let's say it went from 50 and it didn't quite go to 30. It went to 32. I don't know. Again, I'm just making up numbers. That means it didn't go down by 20. It went down by 18. But don't write negative 18. You don't change by negative amounts. Right? So we would just say that that rate of change is 18 degrees C over 15 minutes. It's just a difference. That's it. Equals whatever that equals when you type it into a calculator. Okay? So that's your job. 12 of those, really. Because you've got, again, 3 experiments, and each had 4 sections. 2 things heating up and 2 things cooling down. All right? Again, and do it however you want to. Just scrap it, note it somewhere, get it down. It will be on the official lab report when it's time. And that is the expectation right there. Your answer should look exactly like that, only with your numbers. your change in temperature over 15 minutes. Sound good, folks? Good luck. Go ahead, figure those out.